Okay, this video we're just going to chat about Bronsted and Lowry. There were two different guys. Acids and bases, and definitions of an acid and a base, and what a conjugate acid and conjugate base is. So, for example, say we took a substance like, let's go, HCO3 minus. So bicarbonate ion. And let's throw in some ammonia. Okay, so Bronsted and Lowry, they said that an acid is somebody who can give up a proton, and a base is somebody who's going to take that proton. So when you look at here, this guy this one has a hydrogen, so he can give up that hydrogen. If he gives it up, then this guy here is going to become CO3. Since he gave up a hydrogen, this minus thing has to go down by another minus, so it'd be -2. You can always look on your chart because it'll show you what that ion should be. Plus, so this hydrogen here is going to go over to this guy, so this guy here is going to become NH, now we're up to 4. Since a hydrogen is a positive charge, this will have a positive charge on it. Okay, so that there would be an acid-base reaction. So the bicarbonate ion reacts with ammonia to produce the carbonate ion and the ammonium ion. So when you look at from here to here, this substance here gave up a hydrogen, so that's an acid. That's the definition of an acid, is somebody who donates a proton. This guy here, let me go red with that guy. So this guy here, when you go from there to there, it looks like he gained a hydrogen, or he accepted a hydrogen. So ammonia is going to be a base. Okay, so typically when we're doing Bronsted-Lowry acid and bases, this is an acid, this is a base. Now on the other side, so when we're looking at these substances, let's use blue. So when we're looking at these substances, I want to know which of those are an acid and a base, because this reaction could actually go back the other way too. Typically on this side, we're going to call them a conjugate acid and a conjugate base. I'm not sure which one's an acid and which one's a base yet, but they're going to be conjugate on the right side of the equation. Okay, so now what I'm going to do is I'm going to take a look at what did carbonate do to become that. So if it went back to the way it was before, it looks like it has no hydrogens on the right side here, but as it goes back, it gets one. So a guy that accepts a hydrogen is a base. So this carbonate ion must be a conjugate base, making the other guy have to be a conjugate acid. And if you look at it, to go from the ammonium ion here back to ammonia, it looks like the ammonium ion here loses a hydrogen or gives up a hydrogen, and that's the definition of an acid. You can also take a look at this one here. So this is the carbonate ion, and if it changes to become this one over here, the carbonate ion, so here bicarbonate ion, this is carbonate ion. On this side here, so if this substance is an acid on this side, on the other side it's going to be known as a conjugate base. This one here is a base on this side, and its equivalent, or its buddy on the other side, is going to be known as a conjugate acid. Okay, hopefully that helps you with the conjugate acid, conjugate base idea.